a video about
conduction effect in lab tests
and daily life.
Coming for you. You want war, we got war. We just wanna warn you.
The objectives of this experiment are to examine the temperature profile and determine the rate of heat transfer resulting from radial heat conduction through the wall of a cylinder. Secondly, to investigate the influence of thermal insulation upon the conduction of heat between adjacent metals. The introduction for this experiment is to study data from two types of heat conduction configuration. In example, linear and radial modules. The heat conduction study bench consists of two electrically heated modules mounted on a bench of support frame. One module contains a cylindrical metal bar arrangement for a variety of linear conduction experiments, while the other consists of a disc for radial conduction experiment. Both test modules are equipped with an array of temperature sensors. Cooling water, to be supplied from a standard laboratory tap, is fed to one side of the test pieces in order to maintain a steady temperature gradient. Computer will display the direct reading of the temperature sensors and power input to the heater for ease of monitoring and data acquisition.
The theory of this experiment is to evaluate the heat flow to a solid when the flow is not steady through the wall of a furnace that is being heated or cooled. To calculate the heat flow under these conditions, it is necessary to find the temperature distribution to the solid and how the distribution varies with. Using the equipment setup already described, it is a simple method to monitor the temperature profile variation during either a heating or a cooling cycle, thus facilitating the study of unsteady state conditions. Next, radial conduction heat transfer for cylindrical is when the inner and outer surfaces of a thick wall cylinder are each at a uniform temperature. Heat flows radially to the cylinder wall. From continually consideration, the radial heat flow through successive layers in the wall must be constant if the flow is steady, but since the area of successive layers increase with radius, the temperature gradient must decrease with radius. The heat conduction with insulation is when two surfaces are in contact. Paths of thermal conduction exist only across those points where actual physical contact occurs on the microscopic scale, and the degree of thermal contact depends on the respective surface finish. Air trapped in the gap between each surface acts as a thermal insulator, resulting in a temperature step in the conduction path. This can be reduced by the use of conductive compound, which fills the air space and provide improved thermal contact.
Experiment 1. To examine the temperature profile and determine the rate of the heat transfer resulting from radial state conduction through the wall of a cylinder. 1. Connect one of the water tubes to the water supply and the other drain. 2. Connect the heater supply lead for the radial conduction module into the power supply socket on the control panel. 3. Connect the 6 sensor TT1, 2, 3 and 7, 8, 9 leads to the radial module with the TT1 connected to the innermost plug on the radial. 4. Rotate the heater power control knob control panel to the fully anti-clockwise position. 5. Set the power to the auto position. 6. Set the heater power to 20 watts and allow sufficient time for a steady state condition. 7. Record the temperature at all 6 sensor points and the input power reading on the wattmeter. 8. This procedure should be repeated for other input power up to the maximum permitted. 9. After each change, sufficient time must be allowed to achieve steady state condition.
Experiment 2 was run to investigate the influence of thermal insulation upon the conduction of heat between adjacent metals. First and foremost, you have to make sure that the power is in the off position. Secondly, insert a brass conductor section into the linear module and place an insulating material such as paper or cork, but for this experiment we use paper, into the specimen section and cool section, and clamp it together. And you have to connect all 6 sensors, T1, T2, T3, 7, 8, 9. Rotate the heater power control knob control panel to the fully anti-clockwise position. Next, you have to record the temperature at all 6 sensor points and the input power reading on the wattmeter. And last but not least, this procedure should be repeated for other input power up to the maximum permitted when T equals to 100 degrees Celsius. In conclusion, the length, power, the inner radius, the outer radius, inlet temperature, and the outlet temperature are essential in determining the thermal conductivity of the insulation material. The thermal conductivity for experiment 1 and experiment 2 were calculated using a specific formula. The thermal conductivity was acquired to show how good of an insulator and insulation material are. By the end of this experiment, the objectives were achieved, which are to examine the temperature profile and to determine the rate of heat transfer resulting from radial heat conduction through the wall of a cylinder, and also to investigate the influence of thermal insulation upon the conduction of heat between adjacent metals. Overall, the experiment has been a success as the results obtained were supported much with the theory.